we have discussed. Okay, that component, like what we have in the open VSP. Let me open the software. It's called fuselage wing. Okay, and stack. So like this, we have completed these major components, right? Fuselage, wing, pod, stack. Okay, and next we have the blank. Okay, I will not talk anything about the blank because it's just a blank component. If we add this blank component, then we will get a blank where you can fix your model. Okay, so this is just a blank component. There is no any geometry. Okay, if you need any such blank component, then you can add the blank component and you can add geometry to that particular place. Okay, after this we have the ellipsoid. So I'll be discussing about this component, that is the ellipsoid. Okay, so let me first discuss about the theory part. Yeah, so this is our today's topic, that is creating an ellipsoid by using our OpenVSP software. Okay, so here theory, what it states, ellipsoid in the sense developing of ellipsoidal model. Okay, so ellipsoidal, the name what we have, that will give idea about the ellipse. Okay, as we know in mathematics, an ellipse is a curve in a plane surrounding by two focal points 1 and 2, such that the sum of the distance to the two focal points is constant for every point, for every point. Okay, on the curve, or we can say that it is a generalization of the circle. And here we have the major axis, and half of that major axis we will call the semi major axis, and also we have the minor axis, and the half of that minor axis we will call the semi minor axis. And we have two poles, that is the north and south. Okay, and here north and south, that is the axis of revolution of generating the ellipsoid. Okay, with respect to this axis, okay, you will get the axis of revolution, okay, of this ellipsoid. And flattering, we know that general formula, f is equals to 1 by b by a, b in the sense the semi minor axis, and a, that is your semi major axis. Okay, and eccentricity, eccentricity, e square is equals to 2 times of your flattening minus square of that flattening. Okay, so let me discuss by using the sketch. Yeah, so as we know, here we have a circle. Okay, for this circle, okay, we can drag and we can see the circle has been converted into ellipse. Okay, this is our this axis, that is semi major axis. Okay, major axis, half of that axis from here to here, the half, that's why it's a semi major axis. And this are minor axis, half of that what we have, that is semi minor axis. Okay, and we have north and south pole. Okay, and with respect to this axis, our this model will get rotated. Okay, or revolution. Okay, so that is all about ellipsoidal or ellipse contour mathematics. Okay, and also we can say that an ellipse with a semi major axis of length a and semi minor axis of length b. Okay, this thing you have to remember, because with respect to this only we we have the parameters, okay, ellipsoid parameter in our OpenVSP software. Okay, for this semi-major axis, okay, that parameter we have called a radius, and for this semi-minor axis of length b, for this we are calling in our OpenVSP as a b radius parameter. Okay, and we know this general formula x square by a square plus y square by b square is equals to 1, where a is greater than b, then only that will be like a ellipse object. Okay, and as I discussed about the 2 point control mathematics. Okay, in mathematics, an ellipse is a curve in a plane surrounded by two focal points, such that the sum of the distance of the two focal points is constant for every point on the curve. Okay, so this is what our two focal points, one and two focus points. Okay, so these focus points, okay, the sum of that distance of the two focal points is constant for every point. Okay, here, and the important points you have to remember. Okay, this is the center point, point inside the ellipse, which is the midpoint of the line segment which links the two foci. Okay, in other words, it is the intersection of minor and major axis. Okay, so inside this ellipse we have the center point, this center point. Okay, it is the midpoint of a line segment. This two segment line we have major and minor axis, right? And next we have the major axis. As I told you, this is our major axis, and this one is our minor axis. Why major axis we are calling? Because of the length. Okay, this length what we have along x, that is the large as compared to the y length. Okay, which means the vertical length is shorter than the horizontal length. Okay, so that's why we are calling that is as a minor axis and the major axis. Minor in the sense small axis, and major in the sense large length. Okay, along that axis, that's why major axis. So other or else we can call like this: the longest diameter of an ellipse is termed as the major axis. Longest diameter, right? So this dia is large as compared to the this dia, y-axis dia. Okay. So you can even differentiate your major axis and minor axis with respect to the dia. Okay. In our OpenVSP also, we will uh, change the parameter, that is the radius, in the sense the diameter itself. Okay. So major axis will be changing in our OpenVSP software by altering the radius. Okay, so that's why even we can say that major axis is the longest diameter of an ellipse. Okay, and that is termed as the major axis, and the shortest diameter of an ellipse is termed as the minor axis. And chord, a line segment that link any 2 point on an ellipse, that is our chord. Okay. And we have focus, as I told you. These are the two fixed points that defines an ellipse. Lactus or rectum, the line segment which passes through the focus of an ellipse and perpendicular to the major axis of an ellipse, is called an lactus rectum of an ellipse. And we know that area of an ellipse can be calculated by using this formula, that is pi into a into b. A in the sense your semi minor axis, okay, semi minor axis and semi major axis, and pi. So product of your pi, product of your semi major axis and semi minor axis, so overall you'll get the area of an ellipse. Okay, so this is all about the theory part about the ellipse. Okay, example, suppose if you uh, have some a value, okay, that is semi major axis value as a 5, okay, and semi minor axis b value 4. So overall area you'll get pi into 5 into 4, that is 62.48. And here we have the second example, okay, where a is 10, b is 5. For that case, 10 into 5 into pi, that is 157.1. So why we are focusing on this component? Because we will do some models, okay, like this, like ellipse plane, okay. So for that purpose, we have to know about the ellipse, okay, because even we have such aircrafts like ellipse planes, or we will design such kind of aircrafts, okay, just for hobby purpose, okay. So that's why that component is included in our OpenVSP software, so that you can design your required such aircrafts, okay, or such kind of model, okay, with some ellipse component and all. If you're adding to your aircraft, okay, then after addition of ellipse component, then you can even do analysis, and you can complete your conceptual part, or the OpenVSP conceptual step, okay. Then you can go for a next step as per your plan. And also we have the plane windows, okay, ellipse type. Okay, suppose if you have designed fuselage and you want to uh, even place the windows, plane window, okay, so that ellipse component you can use, and you can even fix to your fuselage. Okay, so in OpenVSP, how we have the parameter, that is the OpenVSP ellipsoidal design parameter. Okay, so here the ellipsoidal is a relatively simple component. Okay, having only three defining design parameters, that is A, B, and C radia. Okay, radiuses. So these radiuses what we have, that A, B, and C. Okay, these radius define the semi-major and semi-minor axes of the ellipsoid in the body x, y, and z directions respectively for the ellipsoid standard equation. So this component is useful for modeling spheres and oblong geometries, which can be used to represent similar shapes or to stand in for mass property analysis. So whatever I shown in this slide, I'll be discussing by using our OpenVSP software. Okay, so let me open that software. It's already, yeah. So let me delete this. So as soon as yeah, okay. So as soon as I double click on the software, we know that we'll get simultaneously two windows, first window and the second window. First window, that is our OpenVSP window, and second window is the geometrical browser window. Okay, in this geometrical browser window we have components for fuselage, wing, stack, blank. This all is done. So now next I will be moving to the ellipsoid component. So I will select this, okay, and I will add. So as soon as I add, I will get the default ellipsoidal, okay, or default ellipsoid, okay. And with respect to this default ellipsoid, I'll get a new window, that is the component window. Which component window? The ellipsoid component window, okay. So in this case we have the same general parameters what we have seen for this all component which we have discussed in our last classes, like fuselage, wing, stack, and all, okay. So the general component, under this we have the name of that component, color, wireframe color you can change, okay. And material, it's a default material. So if you want to change the material, you can change the material, okay. And yeah, these are like export name and all, no, it's not required, okay. And number of tessellations you can increase, okay. Here I have told in our last class that if you increase the number of tessellations, which means you are smoothing your model, okay. So suppose you have shaded this. So after shading you can observe that okay, because of less tessellation, model surface is not that much clear. Okay, let me take four windows. Okay, see, model is not that much clear, which means the geometrical shape, okay, of the surface is not clear. So you can smooth your geometry just by increasing the number of tessellations. Okay, so if I increase the number of tessellations, which means I can uh, smooth our the particular model what we have in this open VSP window. Okay, so by increasing the number of tessellations, we can smooth our geometry. So initially geometry was like this. See, it was not that much smooth. Okay, so yeah, by increasing the tessellation we can smooth our geometry. And in the second tab we have the coordinates. Okay, like what we have seen for our different components like fuselage, wing, stack and all. Same in this X form we have the coordinate system. Okay, which means you can change your model location along X. So here we have three axes, X, Y and Z. Okay, X, here is our X axis. So if I alter my this X location, then that changes can be seen. Model is getting translated along X, and similarly Y, you can change your model location along Y. So here is our Y axis. Okay, so that's why that model is translating along Y, because I am just changing Y location. That's why the model is moving along Y. Similarly Z. Okay, and you can rotate your model along X, along Y and along Z. Okay, and you can take symmetry part along plane, that is XY plane, YZ plane and YZ plane. Okay, which means if you want the symmetry of this model, okay, along the plane, that is XY plane, okay, or XZ plane or YZ plane, and just on this all checkbox. So whichever checkbox you will on with respect to that, you will get the symmetry of this model along that plane. Okay, so here I have clicked this checkbox. Okay, XY, I have on this checkbox. XZ, sorry, XZ checkbox, it's on. That's why here we have the symmetry of this model along the plane. Which plane? X and Z plane. Just I'll change one window into four window into one window so that you'll observe. Okay, yeah. Similarly, you can even take symmetry of that object along YZ plane. Okay. Now, if you don't want symmetry of this model with respect to plane, instead of that, if you want the symmetry along the axis, then even that can be done just by clicking on this checkbox, that is X, Y, and Z. Okay, like this. Whichever checkbox you will select with respect to that, you will get symmetry of that component. Okay, or symmetry of that geometry. So I don't want any symmetry part, so that's why I'll just click on none. Okay, and you can increase the scale. Okay, and next we have the subsurface. Okay, by using the subsurface, we can add the type of subsurface, that is rectangular, or ellipse or line, and you can change the subsurface parameters, that is the width, length, height, okay, and where you want to locate that subsurface, that changes can be done. Once you have entered your parameter, then just that parameter will get settled to in this component, and you can observe it. Yeah, so now I will discuss about the main design parameter of this ellipsoid. Okay, that is the radius A, B, and C. Okay, as I given in this slide. Okay, the ellipsoid is a relatively simple component. As we know, it's completely simple component because we have the simple geometrical parameters. That is three geometrical parameters. Okay, that is the radius along x, along y, and along z. Okay, so instead of x, y, z, here just in the open VSP, they have mentioned a radius, b radius, c radius. A radius in the sense the x radius. Okay, let me convert this model shaded into none. Okay, so here, yeah, let me even delete the surface. I don't want surface, subsurface. I'll delete this subsurface. This also. Okay, yeah. Let me completely delete this model. I'll add once again just to show you the texture part. Sorry, the sketch part. Yeah. See, here we have the ellipse along x plane, along y plane, and along z plane. Okay, so in this design tab, we have three parameters. Okay, A, B, and C. Okay, A radius, B radius, and C radius. A radius in the sense your this one. Okay, major axis radius. Okay, along x axis, that is the length radius. Okay, and also we have the b radius. B radius in the sense the major, yeah, minor axis. Okay, b radius in the sense the minor axis, or the width you can call. Okay, and z, that is the vertical radius. C1, what we have, the C radius, that is Z radius, okay, or vertical radius. So here if I change this A radius, you can able to see along the x, this is our x axis, y axis, and the z axis. Okay, red color is the x axis. Okay, blue color what we have, that is z axis, and green color what we have, that is y axis. So if I change my a radius, okay, with respect to that x, what we have, the ellipse, okay, its radius is increasing. Okay, similarly, second one, that is b radius. Okay, in the sense the width radius, or y axis radius, this one, major axis, minor axis. Okay, and your vertical radius, or along z. So that is what mentioned in this slide. Okay, So the ellipse is a relatively simple component having only three defining design parameters: A, B, C, radii. Okay, or radiuses, three radiuses. So these three radiuses defines the semi-major axis. A1 is the semi-major axis, and B, that is the semi-minor axis of that ellipsoid. Okay, in the body x, y, and z directions respectively for the ellipsoid standard equation. So this component is useful for modeling spheres and oblong geometries, okay, which can be used to represent similar shapes, okay, or even to design ellipse type of planes, okay, or plane window. So now let me um, delete this and add once again so that we can go in a deep about this ellipsoid model. I'll share this component and I'll change the window, that is 1 into 4. Okay, I'll increase the tessellations because the geometry is not smooth. To smooth this geometry, I'll increase the number of tessellations. Okay, yeah. So here we have an isometric view. Okay, left view. Okay, and top view and front view. Okay, so now let's click on this geometry under the tab, the design tab. I'll increase the A radius. This one I am increasing A radius. Okay, major axis radius. So just observe major axis length or overall diameter is increasing because here I am disturbing that A radius. Okay, major axis radius or major axis length is increasing because of that option which I am using here. Okay, I am altering that A radius. That's why along that A or along the major axis length or overall radius is increasing. Okay, similarly along B, this one, okay, minor axis length is increasing or overall minor axis radius and dia is increasing because only I'm disturbing to that parameter. Okay, so only that parameter is changing. Okay, and last one we have the vertical radius or C radius along z axis. So like this you can change your ellipsoid model or ellipsoid geometry by altering this parameters. Okay, that is the open VSP ellipsoid design parameters. Now suppose you have a fuselage. Okay, I'll add the fuselage. I'll share this fuselage and I'll select the ellipsoid. I'll move this along X and I'll change the design parameters like this. Suppose you are looking to design this kind of fuselage, then that can be done. I'll change the location along X. So if you're okay with this kind of model, then even you can have a different views. Again, you can select your ellipsoid and you can come to the design parameter. You can change. So the radius in B or in C. Okay. So by changing that parameter, you can generate any kind of ellipsoid of any shape and any size that you like. Okay. I'll delete the fuselage. See, in this case, suppose you'll maintain x a radius 0 and you'll enter. Okay, so you can able to see this completely flat ellipsoid. So if you want this kind of flat ellipsoid or ellipses, so you can create such type of flat ellipsoid just by maintaining any one parameter 0. If you don't want, then just increase the length or enter any one value. Okay, a small value along any one axis, A radius or B radius or C radius. Okay, just enter a small value, then that overlapping what we have seen. Okay, so see here, if I maintain this 0 and I will enter here, because of the overlap, surface is not that much clear. Okay, so that's why just keep a small radius for that overlap part, so that you can avoid such kind of overlapping surfaces. Okay, and suppose if you have fuselage. Okay, and I'll share this fuselage. And now you want to use this ellipsoid as a window, then just you can do little alterations and you can fix as a window. Change location. Yeah. So now easily I can move this. Okay. Rotate this along 90. Okay. So I'll move along X. Roughly I'm placing, okay. So roughly you can place. Yeah, let it be like this. Change the design parameter. Yeah. Okay. Now I'll move along the X like this. Okay. So once you okay with the location where you want to locate your uh, fuselage window, then just place there. And even if you want to do the alterations, okay, if you want to change the design parameter of that ellipsoid, you can change. Okay, and you can fix that component to the fuselage. Okay, and same what we have the ellipse plane. Okay, that type of say this kind of ellipse plane, same ellipse plane one can be done. Just increase the parameter. Okay, and change along X. Okay, and after that you can do alteration to your fuselage. Okay, you can increase the length and the cross section and all. Okay, so this is all about the ellipsoid parameter. Okay, thank you to all. So we have done with the ellipsoidal. Okay, so tomorrow we'll be discussing about the next component what we have. Okay, so thank you to all. We will continue tomorrow.
Okay, thank you, sir.
Okay, thank you.